Hello, here we go. We are going to talk about logarithms today, logarithmic equations, and how to solve them. We're going to start with a pretty long page of notes, so remember to just pause as you need to. So when we have logarithmic equations, we're going to start by dealing with type 1, which are when a log equals a log. How do we handle that? Okay, so step 1 says to condense each logarithm, right? We want to condense it, make it shorter, put it together, right? Following our logarithmic properties, which is what we've been working on up until this point. Then we've got step 2. We're going to use the one-to-one property. We haven't even listed that yet, so let's go ahead and list that. That property states that if the log base b of m equals log base b of n, well then that means that m equals n. You can basically ignore the log base b parts and just set m equal to n, or set one side equal to the other side. So then once you've done that, you can do step 3, which is solve for the variable using PEMDAS. And if you notice, I write the E in PEMDAS like an exponent to remind myself that E stands for exponents. Step 4 is really important, and people like to skip it, so please don't skip it. I'm going to try to make a big deal out of it today so we don't forget. We're going to check for extraneous solutions, or solutions that don't work, solutions that are outside of the ability, right? So an extraneous solution gets written as, and then if you would please have a red pen or some other color out to make this really noticeable, gets written as no solution. That would be really important. And it's when a logarithm is negative. So an extraneous solution would be if we got a solution that said like x is equal to 4, and then we plug 4 in to our problem, and it gave us log base 6 of negative 20. Well, we cannot have a negative log, so that would be an extraneous solution, and we would write no solution. In your red pen again, please write nice and big, all caps, whatever you need to remember. A logarithm cannot be negative. Our little divider space, moving it up. As always, pause when you need to. All right, our next section is going to be a PEM, I don't even like how that looks, let me start over, is going to be a review of PEMDAS, all right? So it would be P to the E, M, D, A, S, PEMDAS, and we're just going to review. Make sure we all remember the rules, right? P is parentheses, or grouping symbols. Some teachers actually call it GEMDAS instead of PEMDAS, so that it's all grouping symbols, but I'll do it the old-fashioned way and then give you examples. So grouping symbols like absolute value. And then since I am a visual learner, I'm going to take my red pen again and give me big absolute value signs on that. Right? Because absolute value are those long sides that are straight that mean whatever's inside has to come out as a positive number. because it's doing distance from 0. Or the top or bottom of a fraction are also grouped together. And then on a new line, I'm going to remind you that PEMDAS means that we do what's in the grouping symbol first. Whether that's the parentheses or the absolute value sign or being everything on top of a fraction, that kind of thing. We do that first. All right. Next, let's talk about the E. Like we said, the E is for exponent because we do the exponents next. Following all of the exponent rules and properties from Module 6 if you're in the HMH program, from wherever you did exponents and their properties. We've done them since like the so many rules that we have was since Algebra 1. And then you practice them more in Algebra 2, and now we're using them inside of problems in Algebra 2. So much to remember, right? It's also, if you're in my class, it's also what we did our big project poster on during finals week. So that's what we've seen it before. All right. Next, we have multiplication division, and we have it written at the same point because we don't multiply first and then divide first. We multiply and divide in order from left to right. So let's write multiply or divide in the order they appear from left to right. And you're like, Ms. Hethko, it can't be that serious. Really, it's not that big a deal. Well, let's look at an example. So if we have 18 divided by 6 times 2, and we'll do that one in the PEMDAS version, or we have 18 divided by 6 times 2, and we'll do that one multiplying first, and we'll see if we get the same answer. So 18 divided by 6 equals 3. 3 times 2 equals 6. Beautiful. Here, we're going to multiply first, right? Because I know what 6 times 2 is. So we get 18 divided by 6 times 2 is 12. But 18 divided by 12 is 1.5. These two are not the same. So this one is wrong. And the one written fully in red is the one that follows PEMDAS's rules. And we have to have rules so that scientists can discuss things across nations, borders, across language barriers, right? If we all follow the same rules in math, then it'll always work out, right? All right, we'll be able to prove each other's proofs and points and everything. Then we have AS. AS is for add or subtract. Again, they get put on the same line because it is not adding first. It is adding or subtracting first in the order they appear, moving from left to right, just like reading. All right, pause if you need to. I'm turning the page so we can practice one or many, right? All right, so we're going to title this one, Solving Logarithmic Equations. For me, it is still the 6th of March. We're going to write it again that we are doing type 1, which is log equals log, which follows the one-to-one property, which says that if I have log base b of m equals log base b of n, then m can equal n. Here's an example of that. If we have log base 5 of the quantity 5x plus 9 equals log base 5 of the quantity 6x. Step 1 said to condense both sides. This is fully condensed. We'll see one in a little bit that is not condensed, so hopefully it'll make more sense then. And then I have matching bases, log base 5, log base 5. So I can change this to 5x plus 9 equals 6x. And at this point, I have an Algebra 1 problem where you are just solving for x. So you should pause and try it without me. Welcome back. I'm going to go minus 5x to both sides. If you did minus 6x to both sides, it'll still work. This one just saves me a step. This becomes 0. So I get 9 equals 6x minus 5x is x. My answer is 9 equals x, or x equals 9. But remember, step 4 says that we have to check for the extraneous answers. So I'm going to write check for negatives. We will do this so many times today that it'll make more sense in a minute. Put a cloud around it. When I grade your notebooks, I will be making sure and checking and taking off points if you do not make the check for negatives cloud. All right? So when I'm checking for negatives, you're like, Ms. Heathcote, x equals 9. It's a positive 9. It's not a negative, so we're fine. Except that I want to know if the log would be a negative. So I have to plug in that 9 into our original equations. So we had log base 5 of 5, and then I have to go times 9 plus 9 equals, so that was this side of it, right? 5x plus 9, 5, the x is now 9 plus 9. And then the other side is going to be log base 5 of 6 times 9. Well, this is 54, so that is not negative, so that's safe. This is going to be 45 plus 9. That will also be positive, so it is safe, right? So my answer has been checked and it is valid. So let's write y. When we plug in our answer for the variable in the original problem with the logs, right? The results are all positive logs. So my answer is valid. Or I used the word safe in class, so I'll write or safe. So sorry that I did not move that up earlier. This would be a good time to pause because I'm going to go to another problem. All right, pause it here. Don't try to copy that while I'm talking about something else. All right, here we go. Next problem. Log base 2 of 1 minus 4n in parentheses equals log base 2 of 2n plus 43 in parentheses. First question is, can I condense? I cannot condense. They are already condensed. So are my log base 2 and log base 2 matching? They are. So I can just write 1 minus 4n equals 2n plus 43. This is now an Algebra 1 problem. So please stop and solve for n. Welcome back. If you're not trying it on your own, you're not going to make any mistakes today, and then you're going to make those mistakes on a test. So you really want to try them on your own first. There are lots of ways to do it, but I would like to not have a negative n, so I'm going to add 4n to both sides. That makes that a 0, so we get 1 equals 2 plus 4 is 6, 6n plus 43. Then I can subtract the 43 to both sides. I have different signs, negative plus positive and a positive. So different signs I'm going to subtract and choose. Subtract, I get 42. I'm going to keep the negative sign, choose the negative sign. That equals 6n. I'm going to divide by 6 to both sides. And we get negative 7 equals n. Beautiful. What is step 4? What is step 4? Step 4 is to check for negatives. Make sure you write it in red pen and put a beautiful cloud around it. This is the part we cannot forget. If you forget, if you do not check, you will absolutely 100% miss at least one problem on a quiz and a test on this. All right. So checking for negatives, I have to plug it back into my original. So I'll get log base 2 of 1 minus 4 times negative 7. And you're like, Ms. Hethcote, we already know that the answer is a negative 7. So n equals negative 7, we have a negative. Again, it doesn't matter if the answer is negative. It's if we end up with a log of a negative once we plug it in. All right? So that's that. Equals log base 2 of 2 times negative 7 plus 43. So we get 1 negative 4 times a negative 7 is going to be a plus 28. I know that's positive, so that's fine. And then we get log base 2. 2 times negative 7 is negative 14 plus 43. I know whatever that is, it's going to be a positive number because the 43 is bigger than the 14. So this is safe or a valid answer. It is correct. Pause here if you need to finish copying. And I'm turning the page. Our next problem to solve, let's go with log base 9 of the quantity 6 minus 3w equals log base 9 of the quantity negative 2w. We check to see if we can condense. We cannot. So I've got log 9, log base 9. I can just get rid of that. And we get 6 minus 3w equals negative 2w. This is Algebra 1 from here out, so please pause. Do it on your own, solving for w. Welcome back. All right, I would like to add 3w to both sides. That becomes 0, so I still have a 6 on that side. Minus 2w plus 3w is just w. W equals 6. What is step 4? That's right, we need to check for negative logs. And a nice beautiful cloud in red pen, well done. All right. So on this side, I have log base 9 of 6 minus 3 times 6 equals log base 9 of negative 2 times 6. Oh, I'm already seeing that this is going to be log base 9 of negative 12, so it is wrong. In your red pen, write no solution. No solution because we cannot have a negative log. That's right, logarithm, exclamation point. And I'm going to draw my arrow to this, right? Like this is the problem. We got log base 9 of negative 12. You cannot. We cannot have log base 9 of negative 12. So there is no solution. Pause here. All right, moving on. Now we have 3 log base 7 of 4 equals log base 7 of the quantity 4a minus 8. Step 1 is to condense. Can we condense it? Yes. This 3 out here is the expanded form. We need to condense it by making that an exponent on our 4. So condensed, this would be log base 7 of 4 to the 3rd power equals log base 7 of 4a minus 8 in parentheses. We cannot condense it anymore, and now we have matching log base 7, log base 7, so I can get rid of that, and I have 4 to the 3rd power equals 4a minus 8. This is now Algebra 1, so solve for a, pause. Welcome back. So my first step would be to do 4 to the 3rd power. You can either look back a few pages in your notes, or you could do it on a calculator, but 4 times 4 is 16. 16 times 4 is 64, equals 4a minus 8. Then I can add 8 to both sides. That'll give me 72 equals 4a. Then we divide by 4 to both sides. This is beautiful because 4 divided by 4 is 1, so I get 1a. 72 divided by 4 is 18. Awesome. So that is our answer. What is step 4? That's right, we're going to check for negatives, right, for negative logarithms. So I got to go back to the beginning. But there isn't even a variable on this side. There are no a's, so nothing's going to mess that up. It's fine. But I do need to check the other side. So we have log base 7 of 4 times 18 minus 8. Well, I don't know what 4 times 18, but I know it's going to be a big number, so minus 8 is not going to be a problem. It will be positive. If you want to work it out, 4 times 18 is 72. Minus 8 will give us 64 again, so it still checks. So we've checked it. It is a safe or valid answer. Nice. All right. Ooh, yay, this one has a fraction. Let's play with that. So what if we have 1/2 log base 6 of 25 equals log base 6 of the quantity 23 minus 4w? The steps are still the same. Step 1 is to condense. Do I need to condense? I do, because this 1/2 needs to go out here, right? Be on an exponent to that 25. So we'll get log base 6, 25 to the 1/2 equals log base 6 of 23 minus 4w. I cannot condense anymore, so my log base 6 is matching, so I can change this to 25 to the 1/2 equals 23 minus 4w. From here, we need to remember what we do with exponents that are fractions, so I'm going to kind of do that out to the side. They become a radical, right? So we get 25 to the 1, and then we get a radical sign with the denominator on it, which in this case is a 2, making this the square root of 25. What is the square root of 25? 5. 5 equals 23 minus 4w. Now it is for sure an Algebra 1 problem. Go ahead and solve for w. Pause. Welcome back. I'm going to go minus 23 to both sides. So I get negative 18 equals negative 4w. A common mistake is that people lost the negative sign on the 4w. From here, I'm going to divide by negative 4 to both sides. I'm going to do this part out to the side. So I get negative 18 over negative 4 Divide that by 2 over 2. I get 9 over 2, and it'll be positive because a negative divided by a negative is a positive. So we get 9 over 2 equals W. And assuming it doesn't give us a negative log, that'll be our answer. Write your cloud, check for negatives. I don't need to plug in the 9 over 2 to the left side because there are no w's, right? So I only have to do the right side. So I'll do log base 6 of 23 minus 4 times 9 over 2. I do like to make it a fraction so that my multiplying looks more logical. 2 goes into 4 twice, so now I can do 2 times 9. So we end up with 23 minus 2 times 9 is 18. And that equals 5. 5 is a positive number, so my answer checks. It is safe or valid. Pause here to copy. I'm turning the page. One more problem. All right. Here we go. So if we have the problem log base 4 of m squared equals log base 4 of the quantity 18 minus 7m, first step is still the same. Can I condense it? They are already condensed. I have log base 4 on both sides, so I can ignore that part and get m squared equals 18 minus 7m. This is, in fact, an Algebra 1 problem. However, it's been a while in my class, so we're going to review how to do these. So I have a quadratic, right? So it would actually be best to go back to our Module 4, Lesson 4, How to Factor Polynomials notes. So we're going to start by putting it in standard form, usually equal to 0. We're going to say, hey, can I take out a greatest common factor, right? Then we're going to find A, B, and C. Then we're going to, if it's A, we're going to use the X factor, just like we did before when we did that big long worksheet practicing them. If A does not equal 1 and it does not equal 0, then we're going to follow these steps for our slip and slide method. And I will go over that when we do the problem. We also need to make sure that we're looking for specials like difference of squares, sum or difference of cubes, perfect square trinomial patterns. We'll do all of that. Okay, here we go. So let's start by making it equal to 0. So logically, I would just move the m squared to the right-hand side, but then I'm going to end up with a negative m squared, and I would like to not have that. So instead, I will move both the 18 by subtracting 18 from both sides, and I'll move the 7m by adding 7m to both sides. Then I'm also going to put it in the correct standard order, right? Putting m squared first because it has the highest exponent, plus 7m next because it has the invisible 1 exponent, minus 18 equals 0. All right. From there, we say, hey, can we take out a greatest common factor? And we cannot. We only have a 1, so there's nothing. I mean, the 1 would be the greatest common factor, and there's no reason to take it out. So would you please find your A, your B, and your C? Pause here. Find them. Write them down. All right. Welcome back. Did you really do it? Make sure you do it, because otherwise you'll make a mistake on the test. All right. The A, we need to remember that there's an invisible 1 there, so A is equal to 1. It is not equal to 1 squared. It is not equal to 1m squared. It is not equal to m squared. Those are all the common mistakes. In this example, A is 1. B is 7. C is negative 18. All right. Then there are lots of ways to factor. The way in my class that we do it is we use the x factor, and I am going to teach it with the slip and slide method because you will need that later. So when we do slip and slide, we do a times c in the top. Well, 1 times negative 18 is negative 18. I also put a multiplication dot in the top of that to remind myself that the top, I have to multiply 2 numbers to get that. And in the bottom, I'm going to have to add 2 numbers to get that. And the number that goes in the bottom is the b. The b we write at the bottom. We put a b at the bottom. Where do we put the b? The b goes at the bottom. So I'm going to put my 7, right? b equals 7. 7 goes at the bottom. Now I'm going to make my list of all the ways I can multiply to get 18. So we're going to do 1 times 18 is 18. 2 times 9 is 18. 3 times what is 18? 3 times 6? Good. 4 times what is 18? No whole numbers, so that's not going to work. 5 times what is 18? No whole numbers, so that won't work. 6 times 3, we already have that one. Now, just to be really clear, what we're doing is I'm going to add these 2 numbers and subtract them to see what I get. I'm trying to get 7. So 18 plus 1 is 19. That's not 7. 18 minus 1 is 17. That's not 7. So that's not going to be our answer. 2 plus 9 is 11. That's not going to work. 9 minus 2 is 7. Oh, those are probably my 2 numbers then. I'm going to write them down. I am, however, going to double check the next one in case a different set will give me the right answer. 3 plus 6 is 9. That's not a 7. 6 minus 3 is 3. That is not 7. So the 2 and 9 must be my answer. One of them has to be negative because I need to multiply to get a negative 18. But I want a positive 7. So I'm going to leave the 9 as my positive, and I'm going to make 2 negative because 9 minus 2 is a positive 7. Negative 2 times 9 is negative 18. And then we put them in our beautiful parentheses here. So we get m minus 2 or m plus 9. Now, we don't need the slip and slide step yet, but I do want to write it down. So I'm going to go from this A, making my squiggly line to right under the 2. And I'm going to write the note that slip and slide would make us divide by A in this step, right? We would actually do it to both underneath the 2 and underneath the 9. But A is 1, so we don't have to do that step here. All right? So now let's write that m minus 2 equals 0 and m plus 9 equals 0, because we have to set both of them up to 0 so we can solve for them. I'm going to add 2 to both sides, and we get m equals 2, so that's possibly one of our answers. Then I'm going to subtract 9 from each side, and we get m equals negative 9. So that is one of our answers. Hopefully. What is step 4? Yes, it is check for negatives. This gets put in a nice big cloud. Beautiful. And so now we got to go all the way back to the top. So we have to check. So when log 4 of m squared, we need to check m squared for both 2 and negative 9, equals log 4 of 18 minus 7m. We need to check it both for 2 and negative 9. All right. So 2 squared equals 4, so that's safe. Negative 9 squared equals negative 9 times negative 9, which equals a positive 81, so that is safe. Now let's do log base 4 of 18 minus 7 times 2. So 18 minus 14, that is 4. So the 2 works in both of them. It is correct. One more time using the negative 9. Log base 4 of 18 minus 7 times negative 9. Negative 7 times negative 9, we get 18 plus 63. That is for sure going to be positive, so negative 9 also works. Right on. Thank you so much. Have a great weekend.